Today I want to go through how to use a Lensatic Compass. That's one of these things here. It's called a Lensatic Compass because you look through a lens to read the bearing. Oh, some people call a bearing an azimuth, but whether you call it an azimuth or a bearing, you can think about it as it's just a way of defining a direction. There are a few different types of these compasses. The most common one is that it's the Cammenga 3H, so I'll be using this today. Just a quick point, I'm not sponsored by any compass manufacturers or anybody else for that matter. Everything I use in my videos is my own property and I've paid for it, so that's that. Normally these are used by the military, but today I'll only be looking at it from a civilian perspective, how we would use this to navigate around the hills. So I won't be talking about polar plots or directional adjustments or observer target factors, etc., etc. I do teach those topics, but not today. That would be a different video. The first thing I'll do is I'll go through all the parts of this compass so that you know what I'm talking about later on. And after this, we'll go through the 5 very basic skills that you'll need to have to be able to use this compass or one like it to navigate around the hills. Those 5 skills are how to take a compass bearing to a ground feature, how to take a bearing from a map and use it, how to follow a bearing and stay on that bearing, how to find your location on a map, and also how to deal with and adjust for declination. So once you feel comfortable with those 5 skills, then you'll be able to use one of these compasses to navigate in most types of terrains in most conditions. These 5 skills, by the way, they're not standalone skills. You need to be able to mix them together. As an example, you need to be able to take a bearing to a ground feature to be able to find out where you are on a map. You need to be able to adjust your compass for declination to be able to follow the bearing. Okay, so we'll go through all those 5 things as we go on. So the first thing to do is go through all the various parts of this compass, just so that you know what I'm talking about later on. Oh, I'll describe each part of this compass in a way that we would describe it in England. Other countries may have different names for each individual part. I've just briefly been looking at this compass and I found 21 individual parts to it. So if you've been in the military or you are in the military and I miss anything, just let me know in the comments, but I found 21. So rather than using my finger to point, I'll use a stick. I know, I should have laser pointers, shouldn't I? Make it a lot more professional, maybe a green screen or AI graphics behind me. But all I've got is, I've got a rock and I've got a stick. That'll have to do today. What I'll do when I get home, everything I say in this section, I'll put it onto a side screen just to make it easier. So the 21 parts that I've found, I've got the body, which is everything, basically it's everything in green. And the body is normally split into 2 sections, which is the base, which is this part here, and you've got the lid, which is this part here. And the other main part is obviously the compass. So you've got the base, the lid, and the compass. Everything is attached to one of those parts. So number 4, we've got a hinge, which is, it allows the lid to open and close. Number 5, we have a 1 to 50,000 scale roamer here. You can use this on a 1 to 25,000 map. Just when you're taking a measurement for distance on a 1 to 25k map, then just half the distance that you get. So in other words, on a 1 to 50,000 map, it would be, I don't know, 4 kilometers between 2 points. On a 1 to 25, it will be 2 kilometers. The next thing you've got is inside the lid itself, you have the sighting wire. These are the names that we use in England. They may be different names in different countries. So we have the sighting wire. At the top and the bottom of the sighting wire, we've got 2 tritium vials. They just make it easier to use it at night. Next thing we've got on the top of the lid here, we have the top notch. In some cases you can use this top notch instead of using the wire. I'll go through how all these various bits are used in a moment. That's really everything there is on the lid. You know, the tritium marks, the wire and the top notch. Just behind the hinge on the main section on the body, you have the clicker. The clicker is used, it tends to be used by the military. I'll hold it up to the microphone so hopefully you can hear it. Okay, it's used by the military to set the direction of the compass at night or in limited visibility, reduced visibility. Each time it clicks, the bezel rotates 3 degrees. Okay, so okay. Now the bezel is the black circular ring which rotates like this. Inside the bezel you have the glass, the protection glass. This stops any water or grit or getting into the moving parts. Okay, inside the underneath the glass you have the magnetic disc, and this has got numbers written onto them. The black numbers running around the outside, they are NATO mils, and inside you have degrees. So 1, 2, so NATO mils and degrees on the inside. What are we up to? I think that's number 15. I think we're on 15. The next thing we got, and it's printed on the underside of the glass, which is the index line. This is quite important. So when you rotate the bezel, the whole, you know, the top spins, but the glass doesn't. So the index line always stays pointing directly at the wire. Then what you've got on the magnetic disc is you have the north pointer. Once again, this is, it just literally, it follows the magnetic field lines in your area, and as the name suggests, that it just points north. That's all it does. Also on the disc itself you have the west and the east cardinal points. Those are marked. Once again, they have tritium on them to make it easier to use at night. So that's really all you have. I mean, these compasses are actually extremely simple. They're designed to be very basic, so that in the how can I put it, in the expected conditions that they're going to be used in, there's not much to break. Okay, so next thing, attached to the base we have the lens bracket, which is this section here. Okay, inside the lens, the lens bracket, by the way, when you press it forward, the magnetic disc lifts off its central pivot and it stops it moving. That's so that when you put it in your pocket or inside a rucksack or whatever, it stops the magnetic disc. It reduces the chances of it becoming damaged. So whenever you're using this, you have to make sure that the lens holder, the lens bracket, is fully back or quite far back. Inside the lens bracket we have the actual lens itself. This is what you look through to see the small numbers that are printed on the disc. In the top of the lens bracket you have the lens notch, which is just a slight elongated gap that you look through, and you would place, so you would sight from the notch to the wire to your destination or your target in some cases. And the last thing we have is the thumb loop. I mean, obviously we've got the I've not counted the what would you call it, lanyard holder, which is this thing here. I've not even counted because it's not necessary for the operation of the compass, whereas everything else is. So the last thing we've got is the thumb loop, and as the name suggests, it's literally for putting your thumb through so you can hold the compass. There are a number of points on these compasses with tritium vials. They glow at night, and it means that you can use the compass in reduced visibility. That's all they do. Tritium itself doesn't glow, and I know that's what it says on every website and every instruction book in the world, that tritium glows. It doesn't. I've actually made a video explaining, if tritium doesn't glow, why does it become illuminated at night? I've made a video about that. I'll put the description. I'll put the link in the description box. So that's all the parts of the compass. So let's carry on. So that's all the various parts of the compass described. So let's start on our 5 skills, and the first one being how to take a compass bearing to a ground feature. So you won't need a map for this section. I suppose the first question would be, what is a ground feature? This is just my idea, so other people may disagree or may have different ideas. I would say that a ground feature is anything that is on the ground, it doesn't move, and you can touch it. As an example, a wall, a bridge, a forest, a stream, a building, and so on. They are ground features. But other things on the map, such as the grid lines or location names, you can't touch them, so they're not features. Oh, and before anybody comments, contour lines definitely are ground features. Most things that are on the map indicate where something is, on the ground. A contour line simply indicates where the ground is a certain height, and you can definitely touch the ground. So the contour lines, before you comment, contour lines are ground features. So the first one of our skills that we need to practice is, how do we take a compass bearing to a ground feature? Let's say that I want to navigate from here up this hill, I don't know, let's find something, to this rock. I want to go to that rock, and yes, I do know that it's a silly example. It's an instruction video, bear with. I need to know what my bearing is from here to the destination. Don't forget, you can think about a compass bearing or an azimuth as a direction. You can think about it this way. Imagine that you're standing in the center of a circle, and that circle is divided into 360 equal segments, and on the edge of the circle is your destination. So if I've got a bearing of 123 degrees, I will head off from the center of the circle towards the 123rd segment, being that 0 is at north. Okay, so let's say north is that way, 123 gets me to my point, gets me to my destination. If I want to walk on a bearing of 345 degrees, then I would walk from the center of the circle towards the 345th segment of the circle, being that north is 0 again. Okay, now most lensatic compasses like this, you'll also have NATO mills. NATO mills are just another way of defining the segments in a circle, but there's a lot more of them. So 360 for a civilian it's as accurate as you'll ever need to be. Anyway, so let's get on with it. I'm walking from here to that rock, and I'm going to use my compass to do that. Now, I could, in this situation, just stand here and I can see the rock over there. I don't need a compass, do I? It's just absurd. But normally, when you're navigating, you're not going to be navigating, what's that, 10 degrees. You're going to be navigating much further, maybe 1 or 2 kilometers, or 3 or 5, or however far. In complex terrain, you may end up walking sort of 30 or 40 meters before you take another, check your compass. But for today, as you can see, I don't really need it. So what is the point of actually using a compass? Is there a reason for it? The simple answer is yes, because between where you are, or where you're going to start from, and your destination, there may be dead ground. Dead ground is, it's any ground that you can't see from wherever you happen to be at the moment. As an example, if you're looking from one side of a valley to the other, you may not be able to see the bottom of the valley. So that is dead ground. If I was to, instead of walking to that rock, if I was to go to the other side of this small hill, then everything on the other side of that hill is dead ground because I can't see it. And dead ground changes. So you may be walking along and what was dead ground, you can now see it. So it no longer is. Or you may be walking along and you can see a piece of terrain, but after so many minutes of walking, all of a sudden you can't see it. So the ability to use a compass is very important. Anyway, we'll go through that later on when we go through how to follow a compass bearing. So there are two main ways to hold compasses like this. There are other ways, but these are the two that are normally used. There's a center hold technique. I'll demo it. All you do is you open the compass fully, so you open the lid fully, extend the lens bracket so that the magnetic disc, the compass section in the middle, can actually rotate freely. And then all I'm going to do, let's say that I want to walk in, I'll stand here because hopefully you can see what I'm doing. I'm going to walk in that direction for some reason. All I'm going to do is put my thumb through the thumb loop, okay, and put my index finger up the side of the compass. So it's like this, okay? If you're using your other hand, do the same, but put your index finger up the side of the compass. So you're holding it like this and you're supporting it on the, to keep it nice and solid, use two hands, okay, so it's there. And then all you're going to do is, I'm going in that direction, I'm going to point my shoulders, my chest, my hips, my knees, my toes, and my index finger. I'm going to point at my destination. The reason for doing this is not just, you know when you go on courses and people say, do this just because that's how it's always been done. And you think, well, that's just silly. It shouldn't have been. You just don't need to do it. But sorry. But in this case, it is important. Hold it so it's like this. So it's inside, in front of your chest. And you can look at your target. Your whole body is facing the way you're going to go. You're pointing at your destination. Hold it like this so you can actually see, you're looking down at the compass and you can look up and you're solid. And then all we're going to do is rotate the bezel as it clicks like this until the tritium mark is directly over the north pointer of the magnetic disc. So it's here, like this, and it's there. Okay, once again, this thing about facing the way you're going to go, it's you don't have to, obviously, but I do. It's just much less likely to go wrong. And if something makes things more likely to succeed, and it doesn't take any extra effort, then, you know, don't start, I'm going that way, hold your compass like this, and yeah, I'm going that way. You know, center hold technique, it really is. So rotate the bezel until the tritium mark is directly over the north pointer, and the bearing is shown underneath the index point, the index line rather. So once again, there, rotate, point, and now your bearing of 1, 2, 3 degrees or 3, 4, 5 degrees, whatever, is the number that is directly underneath the index line. Okay, so that is the center hold technique. Most of the time when you're civilian navigating, is that a good way to put it? Civilian navigating? Navigating as a civilian? You know what I mean. That is quite acceptable. The other way to do it is the compass to cheat technique. Now in this case, I've seen lots of different ways of doing this on different videos and different websites. So years ago, I actually went back to the American Army navigation manual, and I think they actually got it right they got it right first time. So this is how I do it. If you want to change it or you've been shown differently, that's up to you. All I'm going to do is I'm going to put the lid, so it's like this. So it's at approximately right angles. It doesn't, people say, oh, if it's a few degrees out, it doesn't make any difference, honestly. Approximately right angles, so it's like this. Now, this is the thing. Where does the lens bracket go? What angle should this lens bracket be at? And this is the thing. There is no correct answer. People will say it must be at whatever angle or this, that, and the other. They're all wrong. They're all wrong and I'm right. Don't tell my wife I said that. But I'll explain why. You and I, you're watching your screen and I'm talking to my camera. We are different. We are taller or shorter or fatter or thinner or left-handed or right-handed, or we are made differently. And that includes our eyes. We all have different focal lengths. In other words, if you can, I can read those numbers when they're here, and I can read the numbers when they're down here. Some people can't, they have to wear glasses. We are all made differently, and this is the reason this moves like this. The American military got it right in, when they designed this, or whoever designed it. Yeah, that allows that. So what you do is this. I'm going this way now, for some reason. Put your thumb through the loop again. Support it with your other hand, just to give it a nice solid base. Okay? And then hold it up to your cheek, and hopefully you can see that. So now I'm going this direction. So what we're going to do is we're going to hold it like this. I am now looking through the lens at the numbers. So it's like this. And this is what I said, we're all made differently. Now, to me, the numbers there are slightly blurred. So I'm going to move the lens bracket slightly forward. A bit more. Perfect. So I can now see, because my eye's focal length just happens to be from there to there through that type of lens. But once again, we're all made differently, so there is no correct way of doing this. Once you've used these a few times, you will very quickly get used to your own personal angle. Okay, so hold it like this. If you want to, you can close your other eye, but I tend not to. Look through the lens at the numbers, and I can actually see the index mark now is directly on, surprisingly, the 1, 2, 3 compass bearing. On most of my videos, I follow an awful lot of directions that just happen to be 1, 2, 3 degrees. But anyway, so I'm looking through the notch to start with. Look through the notch and then through the wire, and place the wire on your destination. So it's like this. So I'm looking through the notch to the wire, and I'm placing the wire on the destination. Then, without moving the compass, it's quite important, change your eyes and look downwards through the lens, and then look at the numbers. Do it a few times. Look through the notch, through the wire to the destination, and then look at the numbers. So it's like this, there, and I've got a nice and solid, I've got a bearing to whatever happens to be over there I'm going to, and I've got a bearing of 1, 2, 3 degrees. This is fine. So now what do we do? We need to set, remember on the center hole technique, the tritium mark was rotated, the bezel was rotated, so that the tritium mark was directly over the north pointer. What do we do now after we've done the center hole technique? Well, what we do, I know that my bearing is 1, 2, 3. Simply rotate the compass until it's pointing, until 1, 2, 3 is underneath the index mark. Rotate the bezel until it is over the north pointer, and my compass is now set. So that's 2 ways to take a compass bearing to a destination, or to a ground feature. And they both happen to be 1, 2, 3 degrees. You can use this, the center hole technique, which is there. So your whole body is facing the way you want to go, and you point your finger literally at your target. And then look down, rotate the bezel. The other method, center hold, approximately right angles, adjust the lens for your own eye's focal length, look through the notch to the wire, place the wire on the target, and then read the numbers. Once you've done that, you've got a bearing of 3, 4, 5 or whatever. Set the compass so that 3, 4, 5 is underneath the index line. Rotate the bezel until the tritium mark is directly over the north pointer on the disc. So that's 2 ways to take a compass bearing to a ground feature. The second skill is how do we take a compass bearing from a map and put it onto our compass so that we can follow it? This is probably going to be the shortest section because it's the simplest, but this is one of those things, it's very easy to learn it, but it does take a little bit of practice to become proficient. So please do practice this. So I'll zoom in so you can see what I'm doing. So here's my map, and let's say that I want to plan a route to go from the base of the tarn here to somewhere, let's say this road junction here. So it's only a short distance. Now all I'm going to do is fully open the compass and then place the compass so that the long straight edge is touching the start point and the destination. So it's going to be like this. Oh, just a quick thing. If I was going from the road junction to the tarn, a tarn, by the way, in this area is just a large inland lake. The saying with these compasses is, I walk the wire. I think that's a Johnny Cash song, is it? I walk the wire? I don't know. So if I was going from here to there, I would walk, you always walk towards the wire. So from the road junction to the tarn, the compass would be like this. But I'm not, in this case, I'm going from there to there. This is probably the most common mistake that people do with these compasses. They have the compass literally pointing in exactly the wrong direction. So all I'm going to do is get the edge of the compass, so it's now touching the start point and the destination. And then simply rotate the bezel. Now, if you look at the map, you've got horizontal lines and vertical lines. You want the tritium mark on the bezel so that it's going in the same direction as the vertical line, so it's pointing straight up the map, northwards. Now, as this clicks round in 3-degree increments, sometimes you're not going to get able to get it exact, but for civilian walking, it's always going to be near enough, 1 or 2 degrees. So rotate the bezel until it's like that. My compass is now set. If I was to arrive at this point here and I wanted to walk in that direction towards there, all I do, pick up the compass, rotate it until the north pointer is directly underneath the tritium mark, and I would walk the wire, so I go in that direction. Or there are other ways to do this, but I'll go through that when we go through how to follow a compass bearing. But my compass is now set, and as you can see, underneath the index line now, if we allow the disc to freely rotate, I have a compass bearing of 118. Okay, but it's by the by. The main thing is the tritium mark is directly over the north pointer, so I walk the wire. Let's do another quick one of those. Let's say I want to go from the same road junction to this wall track junction here. So for some reason I want to go in a straight line. Don't forget, the straight edge touches the start point and the destination. Okay, that's that. And I'm walking the wire. I walk the wire so it's in that direction I'm going to go. Then simply rotate the bezel until the tritium mark is pointing straight up the map. And that's it, my compass is now set. I told you that this is the simplest part of navigating, is taking compass bearings off a map. So if I was stood at this road junction and I wanted to go there, all I do, turn the compass until the tritium mark is directly underneath the north pointer, which is there. So I would walk in that direction. I walk the wire, and I've got a bearing of 251. Just a quick point on this, taking a compass bearing from a map. Some people, the majority, will say that your map has to be pointing in a certain direction. They normally mean that the vertical lines on the map have to be pointing north. And I understand why they say this. If you want to do that, if you want to point your map in a certain direction, fine, go for it. But you really don't need to. It makes no difference at all to the bearing that you'll get. If you think about what we've just done, we're using the compass as a protractor. When we're taking the bearing from the map, we're not using the magnetic needle in the center that's rotating and points north. All we're using is the edge of the compass and the tritium mark. and neither of those point in any particular direction. You know, it depends on what you do. So if you want to point your map northwards when you're taking a bearing from a map, fine. As I said, it makes no difference, but you really don't need to. And I think it's just adding in something that isn't necessary. And if you keep things as simple as possible, they're much less likely to go wrong. So if we get rid of this, your map, you know, orienting your map, then that's one complete section of the process that's just got rid of, and it makes the whole thing much simpler, you know. But if you want to know how to use a protractor, by the way, with a map, civilians don't tend to, but the military do. I've actually made a couple of videos showing how to use a protractor with a map to take your bearings and what have you. I'll put the link in the description box. So where are we up to? Oh, yeah, number 3, how to follow and stay on your bearing. So somehow you've got your compass bearing. You could have taken it from a map, it could have been sighted it from a ground feature, or somebody could have just told you which direction to walk. But now what we need to do is we need to follow it, and most importantly, we need to stay on that bearing. If you're just going to walk to a large ground feature like a hill or a ridge, or, you know, and there's no dead ground, you can see all the way to where you're walking to, all you're really doing is confirming which hill you need to go to. There may be 2 or 3, so, you know, it's nothing complicated. So either use a center hold or use the, you know, a little bit more accuracy, use the cheek method. Find your hill and then just walk to it. Normally, in the real world, things aren't as simple as that. There will be dead ground, there'll be obstacles, there'll be rivers and marshes and dry stone walls, and there'll be things between you and where you're going to go. So the best thing to do is to break your route down into legs. A leg is just a section of an overall route. So all we're going to do is we're going to use the compass to take a bearing and find something that is along the line of that bearing that we can walk to. A leg, normally when you're walking, you'll say, right, I'll go from here to that wall, turn right until I get to the footpath. You know, that might be 500-600 meters away or a kilometer away. But today we're just using this as an example, so bear with. What I'm going to do is I'm going to walk, let me pick it. Can you see the large rock that's the bottom one on the right as I'm looking at it? Thank you. There are some strange folk walking around the hills today. What I'm going to do is I'm going to use my compass. I'll use the center hold method just because that's the one that I'm more used to using. You know, if you're used to doing that, then fine, go for it. But I'll use a center hold. So I can see my destination. I've got my bearing. So there it is. I need to walk on a bearing of 1, 2, 3. I look along, I identify my destination. It's that large rock up there, the one on the right as I'm looking at it. Now, let's imagine that there are obstacles en route, and I can't just walk from here. It's a training video, so bear with. So what I want to do is, what I don't do, really, really important this, you must never do it. I don't take a sighted bearing on my bearing of 1, 2, 3 and think, yep, 1, 2, 3 on the horizon there. I'll walk towards that and eventually I'll hit my destination. Don't do that. What happens is this. Let's say I'm walking along my bearing in this way. I take my bearing and I start walking. If I come off my bearing even slightly, I'm still walking to my point up on the horizon. I'm still walking towards it, but I was supposed to be going to this rock and I've actually walked all the way past. I've gone in a big arc. If you walk to something on the horizon, invariably you will walk in an arc, and your destination, you know, you could literally just walk past it, especially at night or in the fog or in the pouring rain. Today is totally unusual, the weather in this area. It's not normally like this. But it's good for us. So always walk to something that you can touch, that you can actually arrive at. I want to walk from here to there on my bearing of 1, 2, 3. So I look along my compass and I can see something along that bearing. So I walk to it. So here we go. Yeah, I can see something. So there's something down here. This is along my bearing. I then do exactly the same. Take another bearing, and you keep leapfrogging points. Don't go to something on the horizon. Break it down into legs. Yeah, it's so look along your bearing, find something along the route that you can walk to, go there, and then do exactly the same again, and keep doing that leapfrogging until you arrive at your destination. How simple is that? Now, that's the problem. When people say, how simple is that? Now, this is all well and good. Somebody on YouTube waffling on about how easy things are and do this and do that, and then this will happen. In the real world, it's not as simple as that. We've all done it. I normally watch, you know, these cookery videos on YouTube with a Michelin star chef, and I try to replicate it in my kitchen at home. It's with varying levels of success. So I do understand that it's not maybe as simple as I'm portraying it to be, but you know, give it a go. As a prime example of what can happen, I'm walking in that direction and I'm expecting to arrive at a rock. And I've taken my bearing, I've looked, I've planned it, and along my route is a rock that I'm going to walk towards. So I'm walking along and this happens. I get here and I can't remember, is it that rock or that rock? It's a problem. This happens very often in forests where trees tend to all look the same, especially in the UK, the very large forests, sort of 250 square miles and what have you, they tend to be forestry commission for plantations. So all the trees look exactly the same. So I'm going along and I've got somewhere and I'm not sure, was I heading to this rock or to this rock? The easiest thing to do is walk back to the beginning of that leg. So I've come back here, sight my bearing again, and I know which rock it is. Sometimes though, you've walked up a steep slope or people are starting to get tired, or for any reason you don't want to go back to where, you know, the beginning of that leg. It may be 2 kilometers away, you know, you just don't want to. So there is a way to get around this. What you do is this: you're walking on your bearing of 1, 2, 3 degrees. You come here and you're not quite sure which. Now you can see where you started from. You can see, I don't know, a rock or a gate post or something, you know. And if you can't see it, then walk back until you can see it. You don't have to go all the way back. Then simply point your compass or do the cheek method. Hold your compass like this. Now, when you're following your bearing, normally the north pointer is underneath the tritium mark. So as I'm going along, this is what happens. I come back here, point your compass at where you started from, but this time the south end of the magnetic disc wants to be under the tritium mark. If it isn't, then simply walk sideways until it is. It's not that way. Yeah, so I'm now back on my bearing. So the south end of the compass is exactly along my bearing. It's to where I started this leg from. So I turn around, use my compass again, pick up the bearing, and I now know that I was heading to this rock here. Okay, so things go wrong. It's not, you know, it'd be nice if they didn't. But basically, hopefully you get all that. Now, just a quick point about this. There are lots of techniques to find out sort of how, you know, are you on your bearing and what. I've done lots of videos about this, so if you just scan through some other videos, you'll pick them up. You can't just expect to navigate using a compass. Well, you can if you're doing something, I'm going from here to that rock. It's not a problem. In the real world, that's not how life is. You do need a map. Now, You navigate using a map, not using a compass. A compass is an accessory. That's my personal opinion. Your navigation is taken from the map. Now, I always say, not on the novice and the intermediate courses, but on the advanced courses, definitely. I say to people, when they're doing their route plans and they're planning their journeys, there should be no, what's the word? No surprises. You should know what's going to, and you get that information from a map. I'm going to walk to here and there will be a wall junction. I'm going to walk to here and the ground, instead of pointing downwards northwest, it'll start pointing downwards northeast. You know, there should be no surprises. So I'm walking along my bearing from here to there. I know that I'm going to come to a wall junction. I'm expecting it. I know that there's a stream which I don't have to step over, but I'll see it on my left-hand side and then it will disappear off. I know that there'll be some sort of building. I know that the ground will, the slope aspect will change, the direction that the slope goes down. There should be no surprises. Do not take away from this video that you can navigate just using this compass. You can't. Well, you can, but it's very prone to errors. A prime example, I get a lot of military folk on my courses, and the normal thing that they'll say is, I'm going to walk on a bearing of 345 for 6 kilometers or 5 kilometers. My answer to that is why? Just don't do it. just don't. If you have to navigate on a bearing for 5 kilometers, that means that you're not very good at navigation. It's as simple as that. There is always, I used to be a Himalayan mountain guide in my youth. I know that sounds quite pretentious, but that was my job. Even when you're up in the white stuff, just you look around and everything is just white. There is always something, always, even if it's just a change in the contour lines, something. Walk to that and then start doing your compass work. Get as close as possible. You know, but anyway, that's all that's a different course. Now, we are spoilt in the UK in that using your map to navigate in some countries, I shan't name them, but I know that their maps are atrocious. That's the best way to put it. You can't navigate using their maps. Well, you can, but whether you arrive somewhere you're expecting or not is it's debatable. But in the UK, we are spoiled. So if you're watching this and you're in the UK, go and grab an Ordnance Survey 1 to 25,000 map. The Ordnance Survey produces probably the best maps in the entire world. They're the only organisation that has mapped every single inch of a country down to, and I'm not exaggerating, down to the millimetre. You know, so if you're in the UK, go and get a map, learn to read that, and then learn to use a compass. But anyway, back to Lensatics. I almost started waffling there, didn't I? Let's go and do something else. Now, all this sounds wonderful. I'll walk from somewhere on a map to somewhere else. But there is an obvious problem with this, in that before you can set off following your compass bearing, you have to know where you are on the map. If you follow a bearing of 345 degrees from here, you might end up in this place. If you follow it from here, you'll end up in this place. So you need to know where you're starting from. You need to know where you are. So let's have a quick look at a couple of ways that you can find out. So if you're standing next to a signpost or a wall junction or a bridge over a stream, then it's easy. But most of the time you won't be. You'll just be in an area like this. In this case, there are only two possibilities. You're either on a linear feature or you're not. There is no third option. A linear feature, how would I describe that? I know, I really should make a script, shouldn't I? And write it all down, what I'm going to say. Or get, what are they called? Teleprompters. I could get one of those and balance it on a rock or something. I'm not sure. But even if I had a script, I probably wouldn't stick to it. I'd just start waffling on about some idiotic thing. Anyway, what was I saying? Linear features. A linear feature is anything on a map which forms a line. That could be something, a broad line, such as the base of a valley or a ridge. It could be a man-made line, such as a wall or a track. So anything that forms a line, even where two different types of vegetation join on a map, that would be a linear feature. So you're either on a line or you're not. So let's look at the first option, which is the easiest one. You're on a linear feature. As you can see, hopefully, I'm on a track. So this is a track here that runs in that direction. But I'm not actually sure whereabouts I am on that track. So what I'll do is I'll zoom in on the map. I can actually see behind me a wall goes up there and joins onto a cliff. So the wall butts up to a cliff. So what I'll do is, the first thing I'll do, I'll take a compass bearing to the, I tend to use the center hold because that's what I'm used to doing. I can do that, but I'm more used to this. So let's have a quick look. So I've got a bearing of 224. I've got a bearing of 224 degrees from here to where the wall goes to the base of the cliff. So I'll move the camera so you can see what I'm doing. So the first thing to do is set the compass. Now we took a bearing of 224. So all you do, rotate the compass, make sure the disc can freely spin, and set your 224 so it's directly, I'll get a pointer, so it's directly underneath the index line, which is here. So let's set this to 224, which is there. That is exactly set. So the next thing to do, same as when we took a bearing using the chest hold method, rotate the bezel until the tritium mark is directly over the north pointer. And then after this, get your map. Now the map can be pointing in any direction. It makes no difference for this because we're not going to be using the magnetic section of the compass. Now we know that we are somewhere, let me find out where we are. We're somewhere on this track here. I really should have a laser pointer, shouldn't I? I'll use this stick. So we know that we are somewhere along this track. And we've got a bearing of 224 to where this wall here goes into this cliff, this crag, this set of rocks. So we know we're here, there. So all we're going to do is we're going to put our compass on the map so that it's running, the edge of the compass is running through this point here where the wall goes into the cliff. That's the exact spot there. So we put the edge of the compass on there like this, and then simply keeping the edge of the compass touching the ground feature we took a bearing from, which is this where the cliff and the wall join. So keeping it touching now, all we're going to do, rotate the whole compass until the tritium mark is actually pointing straight up the map. Remember, so we've got the vertical lines, so the tritium mark wants to be pointing in the same direction as the vertical lines. Where the edge of the compass, we know we're on this track, so where the edge of the compass cuts through the track, that is our location. So we are exactly there. Okay, so that's one way of finding your location when you're on a linear feature. So from here, we can now take a compass bearing and set off, or go and have a nice day in the hills. But what happens if you're not on a linear feature, if you're just out in the hills somewhere? Well, it's very similar to what we've just done. The main difference is that you need to take two bearings to two different ground features, and then you plot those bearings on a map, and where those two lines cross, that's your location. So the trick is to find two ground features that you can identify on the map and also on the ground. Now I'm quite close to a road now. Normally I wouldn't be, but it's only an instruction video. So I can see where the wall intersects with the road in that direction and also in that direction. So what I'll do is I'll take a sighted bearing to the where it joins. and I've got 8 degrees. So let's see how we use that. I've got, yeah, it's 8 degrees to the wall and the road junction. Let's put that onto the map and work out exactly where we are. So once again, the first thing to do is to set our compass. We've got a bearing of 8 degrees. So all we need to do, allow the disc to freely rotate and then turn the compass until 8 degrees is directly underneath the index line, and then rotate the bezel until the tritium mark is directly over the north pointer. Then what we do is we get our map. So here's our map. Now we know, we can see there's the wall. I'll use my pencil. This is the wall road junction here. So once again, put the compass so that the edge of it is touching the ground feature, and then simply keep rotating it until the tritium mark here is pointing straight up the map, same direction as the vertical lines. So there's our point, and that is now set. So we are somewhere along this bearing. So I'll draw a pencil line. You don't have to use, what I tend to use, for the video I'm using a pencil to make it easy. I tend to use bits of grass, and so I don't have to mark my pen. So we know that we're somewhere in this field along this line somewhere. The other one I can see is this wall road junction here, and I know that's at 106 degrees from somewhere. So set the compass to 106. Let's have a look. Here we go. Make sure it can freely rotate. 40. Let's have a look. Here we go. Where's it gone? There it is. Right, set the compass to 106 there. Turn the bezel until the north pointer is underneath the tritium mark, and then there's my junction there. Put the edge of the compass again onto this, and then so it's actually there. So then all we're going to do is we're going to rotate the compass until this tritium mark is pointing directly up the map. So let's have a look. That is there. That's pointing straight up the map. We then, let's get it exact, otherwise we'll get lots of comments. So where these two lines cross, that's where I am. I'm here. So these rocks that you can see behind me are actually these rocks here. So that's another way of finding your location on a map when you're not on in this case, when you're not on a linear feature. Before we finish today, let's have a very brief chat about declination and how we adjust, to cope with it. I've just looked online, and if you were in Cape Town in South Africa and you walked for just 1 kilometer, 1,000 meters, you would miss your target by 500 meters if you didn't adjust your compass to cope with the local declination. So you'd head in that direction, but you'd end up over there somewhere. In, what's the other place I looked at? Maine in USA. You're walking 1,000 meters, you would miss your target by 276 meters if you didn't adjust. And that's just 1 kilometer. So imagine if you're walking 5 or 6, so it is really important. So do you remember that when we took a bearing from our map earlier on, we rotated, set the compass on the map, and then we rotated the bezel until the tritium mark was pointing straight up the map in the same direction as the vertical lines on the grid. So when you take a bearing from the map, that's called a grid bearing. You also remember, hopefully, it was a long time ago, that when we took a bearing with our compass to a ground feature, we let the magnetic needle settle, and then we adjusted the bezel so that it was over the top of the north pointer. And because we used the magnetic disc, that's called a magnetic bearing. So you have grid bearings and magnetic bearings. Now, the problem is, in most parts of the world, The lines on your map that go north on the map and the north pointer on your compass, they don't point in the same direction. The lines on the map point to grid north, and the lines at the north point on the compass points to magnetic north. The angle between those two points is called, most people call it declination, magnetic declination. The technical term is the grid magnetic angle, but today let's keep things really simple, so I'll just call it declination. Now, you need to know what the declination is in your area before you set out walking around the hills, if you're going to use a map and a compass. The simplest way of doing it is to go online, just go to Google and type in declination and then your area, and lots of different websites will come up and tell you the declination. There is an easy way to do it with just using a map and a compass, that you can tell the declination in any area on Earth on that particular day, and it's very precise. I made a video showing how to do it. I'll put the link in the description box. So basically what we've got is we've got an angle. This angle may be 2 degrees, 10 degrees, 15, 20, different things. Now they're also east or west. I'm not going to go into all the technical stuff because declination can get awfully complicated if you allow it to. So the trick is, keep it simple. The simpler something is, the less likely it is to go wrong. So once you've gone on Google and you found out that you've got a 10-degree west declination or something, but you've got a west declination, if you go from your map to your compass, you add the declination to the bearing. So you take the bearing from the map, you then add the declination to that before you start using your compass. If you go from a compass to a map, so in other words, you're taking a bearing with your compass and you want to use it on your map as an example to find out where you are, take a bearing off a ground feature and put it on the map and draw a line. So if you go from a compass to the map, you subtract the declination, whatever it is in your area. If you've got an east declination, so you've gone online and it says that you've got an east declination of some amount. If you go from a map to a compass, you subtract the declination. So you've taken your bearing from the map, you're in an east declination area, so you subtract the declination that you take from the map before you start using your compass. If you go from a compass to the map, again, finding out where you are on a linear feature, then you add the declination. So there's west, east. Some people still say, what is it, mag to grid, get grid, grid to mag, add, which is fine. If that works in your area, go for it. But I can't say that on this type of video because it only works in half of the world. So half of the people watching this video can't use it. So I don't do that. Now, the thing is about declination, it does move, but not very fast. So if you're going out today and you know your declination, if you go out in a few weeks' time, technically it will have changed before somebody comments. But the change will be so small, it's irrelevant. Just keep using the same declination. But if you go out in, say, 6 months or a year, then just go on Google again and have a quick check. I tell you one I did find out today. New Zealand South Island. If you take, a compass bearing from, sighted or from the map and you don't adjust for declination in your area, you walk 1,000 meters and you will miss your target by 438 meters. So you go in that direction and you end up somewhere over there. So declination is important, but the trick is use Google. It can get awfully complicated if you don't. So that's all I'm going. I have done an awful lot of videos on declination. So that's it. Today we've gone over the basics of how to use a Lensatic compass. We looked at how to take a compass bearing to a ground feature, how to take a bearing from a map, how to follow a compass bearing once you start walking, how to find your location, and also how to deal with declination in your area. So I hope you found that interesting, and thanks for watching. And I shall now, I'm going to go down and have a well-deserved cup of tea in the cafe, which is just down the road. Thanks for watching.